Hello, now we will solve extra exercise about geometry. It includes Pythagorean theorem, Thales theorem, congruent triangles, and circle, circumscribed, quadrilateral. Let's start. In the figure here, we have a circle C of center O, radius 3 centimeter. Its diameter is EF, and we know that radii of the same circle are equal, so OF equal to OE equal to 3 centimeter equal to OA here. M is a point on D such that FM equal to 4 centimeter. Okay, D is tangent to C at point F. Tangent means it's perpendicular to the radius at point F, making a right angle. So FO equal to 90. Now I'm trying to understand the given well to solve properly. A is one of the intersection points of line MO and C. H is a orthogonal projection from A to EF. That means AH perpendicular to EF at H. Okay, part 1. Reproduce the figure. It will be completed in the other parts. Reproduce means you have to draw it with exact measurement. Now part 2. Calculate OM. Its length is how much? We know that OFM is right triangle. We said that it's a tangent. Since it's a tangent, I can say that D perpendicular to circle C, to the tangent of circle C. So D perpendicular to OF, that means MFO equal to 90 degree. Now apply Pythagoras theorem on right triangle MFO. The theorem states that hypotenuse square, okay, let's write it properly. Hypotenuse square equal to side 1 square plus side 2 square. Hypotenuse is the longest side in a triangle. Here it's OM square equal to first side, which is OF square, plus second one FM square. OF is 3 square is 9, FM equal 4, given 4 square equals 16, so MM square equal to 25, then OM equal to radical 25 equal to 5 centimeter. This is how we find here the value of OM. Now part 3, calculate OH, here this part. Can we apply here Pythagoras theorem? We can, since we don't know the measure of AH. Let's think about Thales. Can we use it here? According to the given, we have AH perpendicular to EF. This is given. We also have FM perpendicular to EF. That means two lines perpendicular to the same third line are parallel. Here I can say that AH and FM are parallel. And since they are parallel, I can apply Thales theorem. On which triangle? Triangle AHO and another triangle which is OFM. We have to write equal ratios. Now OH over OF equal to OA over OM. Here I'm writing the smaller side above in the numerator and the bigger side in the denominator. OA over OM equal to AH over FM. OH, I don't know its value, so keep as it is, over OF, which is 3. OA is also 3, since radii of the same circle are equal, over OM, we calculated in the previous part, it's 5, equal to AH, the unknown, over FM, which is 4 centimeter given. Now, let's use these two ratios. OH over 3 equal 3 over 5, so I can say that OH equal 3 over 5 times 3, so it's 9 over 5, which is 1.3 8 centimeter. Now let's find the value of AH. AH over 4 equal 3 over 5, so AH equal 3 over 5 times 4, which is 12 over 5, which is 2.4 centimeter. Okay, now what to do here? The bisector of angle AOF. Bisector means it cuts the angle into two equal angles. Here is OP, the bisector of angle AOF. Show that OAP, this one here, and OFP are congruent triangles. Let's start. They gave us, it's a bisector, so I must use the angles in the two triangles AOP and FOP. We have, as we said, AOP equal to POF. We also have AO and OF, they are radii of the same circle, are equal. So this is the second one. We also have OP, a common side between the two triangles AOP and FOP. OP equal OP, common side. So I can say that these two triangles are congruent by side angle side postulate. So we directly move to find the homologous element, even if they didn't ask to. Okay, what are the homologous element here? Let's see. AO equal to OF كتبتها. OP common side كتبتها. The third side is AP. It's equal to the third side in the other triangle, which is here FP. Okay, what about the angles? Here we have angle APO equal to OPF. These are the homologous elements since they are congruent triangle. And the last one, OFP here equal to the third angle, which is OAP. So OAP equal to OFP equal to 90 degree. Here we proved by tangency it's perpendicular, so it's a right angle. Now what should we do here? Deduce that PA is tangent to C at A. Tangent, تقول tangent, it must be perpendicular to the radius. And here we proved that OAP equal to OFP equal to 90 degree, right? This angle is 90, so I can say that AP perpendicular to the radius اللي هو AO. Since a line is perpendicular to the radius of the circle, then AP is tangent to circle C at which point? At A, since it's the right angle here. Now the last part. Prove that the 4 points AO, F, and P belong to the same circle whose center is to be determined. Again, look with me at the figure. AOP is a right triangle, so the midpoint, it's somewhere here. The midpoint of hypotenuse is the center of circle. Circumscribe triangle AOF. And OFP is also a right triangle, so midpoint of hypotenuse is the center of circle. Circumscribe triangle OFP. So according to the quadrilateral AOFP, بما أنه OP common side وبما أنه قلنا بالحالتين هي common hypotenuse, the midpoint of hypotenuse OP is the center of circle. Circumscribe this quadrilateral. Okay, that's it. If you have any question, please don't hesitate to contact me.